Hello, let us look at this question, number 6 from year 2011, Form B. Now, first it says the Maclaurin series of ln of 1 plus x is given in this manner. Okay, now they want us to use the series to write the first 4 non-zero terms and the general term of the Maclaurin series for f. But here notice that when you compare f and then the given, so everything's about the same except in place of x we have x cubed. So what we're going to do is this, we're just going to rewrite that. So f of x will be approximately equal to, since we're just going for the up to 4 terms, in place of x we're going to put x cubed. So in place of x we have x cubed minus here x cubed square over 2, and then plus x cubed to the third over 3 minus x cubed to the fourth over 4. That's what I'm beginning. Now, plus dot dot dot. Our general term as well, we're going to have negative 1 to the m plus 1 and x to the third to the m power over n. All right, so that will be my answer. Now, before I continue, I want you to just check it just one more time to make sure that what we have as a general term matches with what's given. So if n were to be 1, you will realize that it will be the first term that we see. So then division by 1, therefore we don't see the denominator, and m plus n becomes 2 over here, and negative 1 to the 2 power is become positive, so that seems to be working out. So that will be the answer for part A. Now, part B. The radius of convergence for the Maclaurin series for f is 1. This simply means that we have x has to be less than 1 or equal to 1. We don't know that yet. So here first I'm going to write it as negative 1 and x, at least x can be greater than negative 1 and then less than 1. But we don't know about the other portion, so determine the interval of convergence. So here let's look at it. What if x equals negative 1? If x equals negative 1, you will see that our series that we have over here will be equal to all negative values. So therefore, it will be, in fact, becomes harmonic series with a negative coefficient. So therefore, in case of harmonic series that's not alternating, this will not converge. So x cannot be equal to negative 1. How about x being equal to 1? But when you plug in 1 for x, here we get this will be alternating series, and then it's going to be harmonic. So therefore, 1 works, because this will be alternating harmonic series. So therefore, we could put down the underline with 1, but not with negative 1. All right. How about C? Write first 4 non-zero terms of the Maclaurin series of this. Now, what are we going to do? You know, for us to write down f prime of t squared, first we know f, so let's write down the f prime first. So here, I'm going to write down the solution for C here. What is f prime of x? Then you will see the first term, derivative of x cubed becomes 3x squared. How about the second one? 3 times 2 becomes 6. So when 6 comes out, we end up getting minus 3 x to the 5th power. And the next one is plus. And then 3 to the 3 power, 3 and 3 becomes what? 9. So x to the 9th power, but 9 comes to the front. So we get 3 x to the 8th power. Minus. Next one is 12 here. So 12 comes to the front, then it becomes 11th power, and then 12 divided by 4 becomes 3. So we have 3 x to the 11th power. That's what we end up getting. Now, plus dot dot dot. Do they want us to write up the general term? Oh, and then in fact that's it. So we just wrote down 4 terms, then we are done with 4 terms here. All right, now. But what we are looking for is f prime of t squared. So I'm going to, in place of x, I'm going to put t squared. So we get 3 t to the 4th power minus 3 t to the 10th power plus 3 t to the 16th power minus 3 t to the 22nd power. So that's basically what we have for the first part. Now, the next one is this. You can see that if g of x is given in this manner, use the first two non-zero terms of the Maclaurin series for g. So now, then what is the first one? So g of x can be approximated using, first term is g of 0. What is g of 0? Then this one has to be 0. Then starting and then ending point is equal to 0, so therefore it becomes 0. Now, then, next one will be this. Next one will be g of 0, we realize that was equal to 0, so we don't have any term. And then g prime of 0. G prime of 0 in this case, you can see that, will be equal to f prime, or f of 0, not f prime of 0. So f of 0 in this case was equal to 0 as well. But as you continually go through, you will realize that only time where we'll be able to figure out would have been this. Since g of x is the integral, essentially, of f prime, what we're going to be doing is this. We're going to be taking the integral of this in terms of t, and then plug in x. Then what we end up getting is this first term becomes 3 x to the 5th power over 3. Second one is minus 3 x to the 11th over 11 power. Next one is plus 3 t to the not t, x to the 17th power over 17, and so forth and so on. Let me just go for one more. 3 x to the 23rd over 23. Now, but what they want us to do is they want us to use the first two terms only. So therefore, here g of 1 can be approximated by 3 over, oh my bad, this one should be 3 over 5. So 3 over 5, and then minus 3 over 11. Then this simplifies into 33 minus 15 over 55, which will be equal to 18 over 55. Now, how do we know? Okay, so we next one is this. It says alternating series converges in this case with individual terms decreases in blah 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 blah. Now, we want to show that the g of 1 is differ by less than 1/9. How do you figure that out? In fact, in order for us to do that, I'm just going to erase this portion a little bit. Part D. Error between 18 over 55 minus g of 1 has to be less than the following term, which will be term right over here. So since x is equal to 1, we get to realize that that has to be less than 3 over 17. But since that's less than 1 over 5, which we are comparing, therefore, the error is less than 1 over 5. All right, so that's basically conclusion of this question. I'll see you later. Bye-bye.